Hello everybody, welcome back to another edition of the Modicon M221 training. I'm your host, Leandro Mada, and today's video we're going to see how to use one of the high-speed counter called the single phase in the EcoStruxure Machine Expert Basic. So let's go to the presentation. So in the previous video we have seen what is a high-speed counter and what we need to use on the PLC. So in order to add this high speed counter, we saw that we just need to go to configuration, select the high speed counter, and then you should have 4 instances, okay, for the high speed counter. In our case, we're going to use the single phase. So if we have this M221, we can have up to 4 high speed counter as single phase, but the total amount will depend on the other configuration. For example, if you have a high speed counter as main or dual phase, okay, then the amount of high speed counter simple will be reduced. We're going to see that later. So once you have access into the configuration of the high speed counter, you just need to click on one of these squares, okay, just to link the high speed counter to one of the instance, and then you should be able to select for each instance which type of high speed counter will be. So in our case, we're going to focus in this video on the single phase. So select a single phase, and this is the view that you're going to have. Okay. Now, once you have this view, there are a few things that you need to know. So the first one is here, the double word. By default, the value of the high speed counter will be in words, but if you want, you can select that as a double word. Then you have the preset, but in our case, as a single phase, every time you, even if you assign a value for the preset, is go to 0, okay? But what is important here are the threshold. The threshold are the levels that you can configure for the high speed counter to reach, and when it's reached, it can set to one of the outputs that you have for the threshold in the function block, okay? So if you want to execute, for example, when the high speed reach the number 10, you can execute something in your code, okay? So that's a little bit of the idea. Then if you, for example, wants to assign an event, okay, and a specific POU or subroutine, you can assign the threshold, the execution of the threshold to execute one of the subroutines. Okay, we're gonna cover that later. Then what we have here is the possibility now to link the inputs. By default, once you select, for example, this high speed counter 0, okay, as a single phase, you must use the input 0, okay, for the pulse, to take the pulses. That this input 0 is related to the fast input, okay? Remember in the previous video that I have already explained which inputs of each Modicon M221 has already defined as a fast input. Then you have more additional inputs over here. Once you select this to use, it will define if it's catch or preset. I believe this one is preset and this one is catch. We're going to cover that later, okay? But it's not mandatory in order to the high speed to work. Another functionality that we have in the single phase is that the reflex output. The reflex output are very important because it compares in the hardware the actual value that you have on the high speed counter with the condition you want to trigger any of these. So when the high speed counter reaches one of these conditions that we have over here, you can execute directly the output, which is good. So saying this, what we're going to do now, okay, in my example, I'm using one inductive sensor, okay, connected to the digital input 0 of the M221. Okay, the idea is to read the teeth, okay, for this gear, okay. In my case, I don't have the teeth, the the gear. So basically, I will simulate the gear using a screwdriver in my case and the sensor. So now what we need to do is to configure in the software this high speed counter. So let me just open new project over here. Going to inactive this. Configuration, this is the PLC I'm using. Let me just configure the IP address so I can connect that later. Okay. If you want to use the high speed counter, you shouldn't be able to simulate the behavior. Okay. Just need to connect to a real target. So configuration, high speed counter. I'm going to configure the first one as a single phase. It's configured as a single phase. Here you can predefine some values. 10, for example. See this one, the threshold S1, okay, it's in red because this one is bigger, so you need to put a bigger value. Okay, now let's see if I'm missing something. So this one, once you check this, it automatically directs this as a preset, and this one to the cache. Okay, let's see the configuration. Is something missing? Okay, that's it. So now we should apply this. Okay, so in this way you have already configured the high speed counter. Let's continue with the presentation. So now it's time to implement the function block. So in order to grab the function block, we just need to go to Programming tab, select this function icon, okay, and find this one, this 1123, which is for the high speed counter function block. So click it and put it on the code that you have, then you should be able to use it. If you double click on that, you should be able to see the high speed counter properties. And once you have configured one of those, you should be able to see that over here. The other way to access to this is to go to the tools inside the programming tab, IO offset and high speed counter. So let's try this code, okay, in the PLC and then download it. So let's go back to the here, programming. So this one, high speed counter. Let's add some contacts over here. Okay, good. Okay, good. So now we need to address this. Let me just double check in the presentation. M0, M1, M2, M10. Okay. So let's go back here. M0, M1, M10 over here. 11, 12, 13. Okay, so this one here you can see that is configured as a single phase, free large. Okay, so here when you double click over here, you can define a symbol. Okay, so instead of using the percentage HSC0, you can assign a symbol. For example, HAC sensor. Okay, you have access to the preset. Here is only visualization because the configuration comes over here. Okay, yes, it's over here. So if you want to access to these values, we just need to enter the name dot S0 or S1 auto P for preset. If you want to use the value now, okay, we just need to go over here. So we just need to use the percentage HSC0 in my case because the first one dot B for value, and here we need to assign this to a percentage NW variable. For example, 10. Okay, there we go. Let me see in our code. Okay, you can see here they have a different symbols. Okay, so now what we're going to do is to download this into the target. So let me just move over here. So let's connect to the PLC and see the behavior. So this one is the PLC. Let me just try to ping it. Okay. M221. There we go. We have connection. So login, download. There we go. So now, if we go back over here, let me just change the view. So I have an HMI application. We're going to see that later, but I have the sensor. Okay. So this is the sensor. Let me just drag this a little bit more. Okay. This is the sensor. Here you can see the value. Okay, there's the actual. So if I don't enable the function block, this is not going to count. So you can see here, you have the red light over there, indication that it's something okay, detecting, okay, but you can see the value doesn't increase. So I can enable now this, and if I put this over here, you should be able to see the counting. Okay, there we go. So I have already specified one of the preset values. If we go here, it should be 10. So let's see what happens when I reach the value 10. 9 and 10. You can see now that the threshold, okay, is activated and remains active. So let's start continue again. Just accommodate this a little bit more. It's in, and now this one is activated, okay, and it continues to be active. Okay, so this is how you can configure or how you can activate this threshold output, okay, configure on the HSC counter, okay. So when the value of the high speed counter reaches one of the thresholds that you have, it activates this output. So now let's continue with the presentation. Let's change the view over here. There. Good. So imagine now that you don't want to see the pulses because probably it doesn't mean anything, and you want to see, for example, you have the gear and you want to calculate how much object have been moving. So there is a small calculation, just a rough idea how you can do. This is just some mathematics over here, but based on the amount of pulses that you count, it will depend how bigger is the move. Okay, depend on the gear that you have and the teeth number that you have. It will give you the idea of the how much the object has moved. So this is a small calculation that you can use in the software. Okay, so if you have the radius of this gear, okay, and you have the number of teeth that you have up here, okay, the tooth number, you can calculate the distance. So you should be able to do something like this. So based on the value that you have, we should be able to convert the integer value, okay, the percentage NWU, in a real, okay, in order to have a better resolution. Then you should be able to multiply for the number 2 and the p and the radius, okay, to calculate the perimeter, all this. And based on this and the amount of number, we can calculate the amount of distance that the object has moved, okay, based on the number of the actual number of pulses. So just go back over here, just move this to the side, okay. So now let's go to the software. So let's disconnect from here. Just go down. Okay, so I'm going to disconnect from here, and now let's add over here the calculation. So what we need to do is to convert this. So I'm going to use percent NWMF 12, 2 points equal um, int to real percentage NW10. So I'm going to convert the actual value into real. So now that we have this, what we need to do is to calculate the perimeter. So here symbol should be percentage MF14, for example, colon equal 2.0 dot 316, this multiply by the radius. So I'm going to specify this percentage MF14 and this one 16. Okay, to calculate this, let me just memory word so we can assign this later. So now that we have the perimeter in this one, what we need to do is to calculate the actual amount of distance. So it should be the percentage MF18. I just assign the variables. So the actual amount of pulses, that should be percentage MF12 multiply by the the perimeter, that should be the percentage MF16. I'm going to put over here, divided by the number. Then I'm going to specify the new variable just to configure. It's 20. There we go. Should be something like that. Let's give some names to this so we can follow the equation. Okay. So percentage NW10 will be the indication of pulses, let's say in row. Now let's go to percentage MF. So we have the percentage MF10, which should be the indication of pulses. Okay, converted in real. Now I got the percentage. No, this one, my bad, is 12. The 14 should be the radius. Okay, so this one should be the configuration radius. And now the percentage MF, which should be the perimeter. So indication perimeter. The 18 should be the actual distance. It's taking time, but I'm going to do it slowly. And this one is the amount of teeth. So configuration teeth number. Okay, apply pulses. Okay, perfect. So this should be working fine now. So here you see that you have the number P. One of the things that you can do for this constant value is to assign, for example, here, pi number. And here I did it wrong. This one is a percentage KF. Yes. Okay, here, pi, float number. So 3.4.16. Oops. 16. Okay, pi number. So instead of using that, you can use the P over here. Oops. 3. Okay. So let's give some values now. I believe in the next slide. Let me just double check. Indications. Okay, so let's give a number. Let's see what's going on. Okay, let's just download this to the controller. Let's create an animation table so we can put this information. So animation table, table HC simple over here, double click. We have the raw value MW10. We have this one, the indication, no, 12. We have the indication of the perimeter, which is the 16, and we have the indication of the distance, it should be 18. Then we have the configuration, which should be the radius, and then we have the number of div F20. Okay, so based on this, we should be able to calculate the distance. So let's connect to the controller. Download. Yes. It's almost done. Okay, and play. So let's calculate the radius. Imagine there is 3 centimeters. Okay, and then the number of teeth should be 1. So for each turn, you should be able to measure the perimeter, which should be 18.8 centimeters. So for each pulse, if we open now the view, okay, just change this. So for every turn, we should be able to see 18 in there, if I did it right. Da, da, da. Forget to do this one. Okay, so for each turn now, okay, we should be able to see the 18 number. So 18, okay, let's go again, 36, almost 36, and so on. Okay, so that should be the the distance that the object is moving. So imagine now that I'm going to preset this with the S, so you can restore value 0 over there. Imagine that the T number is 10. Okay, so I need to count 10 in order to cover the complete circle. Okay, so you can see there 2, 3, 6. Okay, pulses 9. As you can see, is almost the distance is almost the complete perimeter, so we are almost to cover the complete circle. Now it's done. Okay, so that is the idea of this. So imagine that you want to just open on this side. Da-da-da. Let's open the operator terminal expert so you can see how you can change this. Okay, just go back over here. That's all done. There we go. So let's create a small presentation, and probably I can download it to the target, or simple just simulate this. So imagine that you want to communicate with this PLC driver, Schneider master, going to use the Ethernet IP, M221, here, equipment, going to use the 192.168.1.221, okay, which is the IP address of the equipment. Here I see syntax. This is good. Now I'm going to symbol link. No, I'm going to directly connect here. Going to use the amount of pulses. Okay. So this one should be the R pulses. Okay. And I'm going to add another one for distance. So should be external variables here. And let me just go back to the software. So the perimeter should be the percent, no, this one, distance, MF 18 and 12. So 18 and 12. 12 and 18. So here we have the two numbers. So if you want to use the HMI and used to use the HMI ST6 400, okay. Now let's use the screen, and I'm going to use something cool now that we have. If you use the numeric display, let's add this a little bit bigger now, okay. Here, the current value, you're going to use the variables pulses, okay, and going to there's too many pulses. There's 3 details, prefix and suffix. Suffix here I can put pulses, okay. This is something that in the previous version wasn't available. Okay, let me just change the view here. In the details, function details, we have this new and also the prefix. Okay, so sensor 2 points, pulses, and we can also increase the font. So I can try to download it to the controller. Pulses, and here just copy variable distance. Distance, this one, it should be float, 0 float, and let's put 2 details. This one is distance. This one should be centimeters. Okay. I hope you get the idea of what I'm doing. So let's try to download this to the target. So you can see it on the screen. Target. Here, Ethernet. Just going to specify the IP address. I believe I have the transfer mode, but USB cable. Okay, so I'm going to transfer this to the HMI. Hopefully we have the connection. The node setup, understand, the show. Okay, cancel, transfer, cancel, disable, conference transfer. Okay, let's download now. Okay, let's save this, do not understand. Okay, it's transferring now. Okay, just want to show you how you can visualize this in a HMI target, just to give you the full experience. Okay, let's preset this. Okay, and let's start counting again. Okay, we're almost there. So let's increase this so you can see it. Hopefully the light is not going to affect us. Okay, so you have the sensor, the pulses, the distance. So every time I use this, you should be able to count how much is increasing. Okay. So let me see here. Distance 41. Okay, that is something that I haven't checked here. My bad. Decimals 2, 3. Here should be float. Okay. Now it's gonna make more sense. I haven't changed on the visualization here. It was in decimal, now it's gonna be in float. So we should be able to see the real values now. Common mistake. So now let's go to the HMI so you can see it. So you should be able to see the same thing that we see on the PLC 41.46. Okay, the amount of pulses is 22, so it should be the double of the perimeter because we cover uh, two revolutions. Okay, you can see there the value. So if we press this, okay, 0 pulses, resistance is 0. Now let's start the other way around. Start counting again. Okay, goes here. Okay, so just to give you an idea how you can do this. So let's go back now to the software. So here we have how you can convert the pulses into distance, for example. So let's talk about now the threshold. We can configure the threshold level to execute actions. So now is the other way around. So if I got the configuration distance that I have and I multiply that by the teeth number that the gear have and divide it by the perimeter, we should be able to calculate the pulses that we need to reach in order to activate something. So this is the equation. Okay, so let's go to here, go back over here. So it should be like this. So we could directly access into this information. Okay, for example, HS percentage HSC 0 dot at 0. Okay, 2 points equal percentage MW 30. Okay, but okay, this new value that we want to access to the threshold to be activated will be in impulses. So if we want to calculate now, for example, to access in distance, for example, let's use another value, percentage N30. That will be the new value for the sensor. Okay, should be the real to int. We need to do the other way around now. Real to int front the distance configuration that we want. Let's say percentage MF32. Okay, multiply by the teeth number. It was percentage MF20. All this divided by the perimeter, that should be the percentage MF16. Okay, this should be the calculation. And something that I want, for example, I want to add is this comparison block over here, just to specify in case I don't want to use this and I want to configure everything by pulses. Okay, so we should be able to add here percentage MW 99, for example, if it's equal to 1, okay, then you should be able to access into distance to change this. So let's add these variables over here. 99 should be the configuration. CFG type the threshold. Apply. Now let's go percentage MF. Here, I have this MF32, which should be the CFG distance threshold 0. Okay, and I'm going to create the other one for the distance 1, for the threshold 1. Going to save this, go back here. Okay, good. So this one will be the value that will have the conversion for this distance into pulses. So here should be CFG pulses TH0, and this one copy threshold 1 and apply. So this one should be for the threshold 0. Now I'm going to copy this, copy and paste it, okay, and change the 0 for the 1. 1, 1. This is the other threshold, 1. Here the configuration 1. Okay, so I should be able to change the threshold here. Okay, so let's see if there's something missing here. I don't want to clear the configuration, and I want to add. Now let's add it on the animation table here. So I should add these two percentage MF32 34, okay, the new threshold values. So now let's connect to the controller and see the behavior. PC, download, okay. Okay, now, so play, and there we have. So what we need to do now is to configure the threshold. So imagine I have, this one should be when I have the 10, let's configure that I have this distance when I have the 20 now, okay. The first threshold will be at 8 centimeters, okay, and this one will be when I have the 15 centimeters, so we're almost to the 20. Okay, so if we go over here now, what we need to do is to configure this, okay, to the type of the distance. So this value, I'm going to assign the number 1, so it make the calculation, okay. So based on this, in order to access into the pulses, should be 8, okay, and the other one is 16. Let's make this a little bit more different so you can see the difference. 10, okay, so here, and here, number of pulses, 10, again. Okay, so, no, 12. So the first threshold, I want to reach, for example, the 55 centimeters, and the other one next to this one, almost to 55. Okay, probably the number should be 20, so to have a better resolution. So we change the area, okay, the range for the threshold. Okay, as you can see here, if I need to go to 15 centimeters, the amount of pulses I need to see is 5. And this one, if I want to reach the amount of 55 centimeters, okay, the number of pulses is 18. And you can see over here, no, over here not, but on the configuration of the counter, if I use this one, should be the actual configuration. So let's go over here and select the preset just in case. So now what we need to compare now is the amount of the threshold that we have over here, 5 and 18, okay, if this threshold is activated. So close this part. So I'm going to use the pulses one based on this and the number 5 should be executed. Let me just reduce this part so you can see that it's activated. Okay, so the number 5 should be activated if I'm not wrong. Okay, 2 pulses, 3 pulses, 4 pulses, 5 pulses. Okay, you can see the threshold is activated, and now the next activation will be when it reached the value 18 over here. So let's start counting. And there we go. So this is how you can calculate, instead of using pulses, a relationship between the amount of teeth that you have, the tools that you have on the gear, and the radius that you have. So that's to give you a rough idea how you can calculate the distance of the object that have been moving. So what we need to do, another thing here, is the configuration of the events. So let me just go out over here. If you go to configuration, okay, and if you go configuration here, you have the possibility to use the reflex, okay, to activate the output based on the configuration of the threshold. And the other thing is here, the rising edge for triggering the event. So rising edge, this one. Once you do this and apply, here you can see on the task, there are 2 events created. So what we need to do is to create some free POUs here, okay? So in this case, what I'm going to do is to percentage MF 500. Okay, this one will be um, percentage NW 150 plus 1. Okay, this one will be, let's change the name of the PO. So this one will be event TH0. Okay, let's copy again. Copy, paste TH1. And instead of using this one, let's use another variable, 1 and 1. So the idea is to show you that this activates one of the function blocks, okay? So let's imagine now that that's okay. So you can see that we only access one time. So this value will be increasing from 0 to 1, 2, and so on once I enter into the event. So now here we need to link this free POU that we have created into the event. So if we click over here, assign free PO, you should be able to assign it here and assign the other one. So now we should be able to activate this event only one time on the rising edge of the threshold. We have configured over here, rising edge. You can see here, which is the subroutine that is linked to this event. So let's connect to the controller once again. Log in. Okay, PC controller, override application. Okay, there we go. So let's see the values that we have over here. So let's delete these ones. I'm not interested in this one, the preset. Okay, so let's view now the percentage of 50 and 51. So they're in 0. So what we need to do, let's check this one. So when this one is activated, it will execute the action, and this one will be in 1, only just one time. Okay, it's not going to execute periodically like the master or the periodic task. It's only one time. So let's go over here just to show you that I'm going to press it. Where is it? This one over here. So the first one should be in 5, 4, 5. Okay, And why it didn't work? Because I haven't defined it here. The preset, let's go preset, should have the preset first, my bad. So now, should be executed. And 5, okay. So we have the new value 1. Now when I execute, let me just move this one. Okay, I should access this when I have the 18. It should be this one in 1. Okay, let me just move this top so you can see it. So when it's 18, should be able to see the one over there. Okay, now if I reset this again, you can see it only add one, only just one time because it's an event. It's not periodically. So if I reach again the number 5, it will add the number 2. We have the number 2 over there. Okay. So this is how you can work with the high-speed counter in single phase. So you just need to use, for example, an encoder or something that varies very fast, up to 100 kilohertz, and then you can work with this function block that we have seen today. So this is it for the high-speed counter as single. We're going to see the next videos on using an encoder, how we change the different behaviors, okay, along with the encoder and the different configuration of the high-speed counter. So thank you very much for watching this video, and I see you on the next one.